Unit 9 review video. So I'm just going to go through this review. We'll see, we might break it down into multiple videos. We'll see how long this takes. This first page is just a table practicing rewriting each expression as a cube root and then simplifying. Okay, so the left column is what it's starting as a radical, or excuse me, as a exponential. In this case, this is a rational exponent because it's got a fraction. Actually, it looks like, oh yeah, they all are. So they're all starting as rational exponents. So you've got a fraction as an exponent. We're going to rewrite it as a cube root, and then we are going to simplify if possible. Okay, so there's two examples worked out for you. So what we need to remember here, looking at these examples, and we're just remembering our rules, is that when you have a rational exponent, the, I wrote that backward. I want m on top and n on bottom. This is consistent with our notes from before. When you have a rational exponent, your denominator becomes the root of the radical, and the numerator becomes the power. Now that power can be written on the outside of the radical like this, or it can be written on the inside like this. Okay, so those are both correct. Okay, so we're going to keep that in mind as we're rewriting rational exponents as radicals. All right, so you can see in this third one, a lot of these also have powers on powers. So another rule that you need to remember is that when you have a power to a power, you multiply those powers. Okay, so we multiply when we have a power to a power, those get multiplied. So let me get in here with a different color now. So the 5/3 and the 2 are going to be multiplied. So 5 times 2, that's going to be 10/3. If I reduce that a little bit. All right, so I've got 10/3. So now that means the 3, the denominator, is my index of my radical. And then the 10 stays as a power. So I can write it out here like this, or I could have written it in here on the 10. Either one's correct. Now, the fact that I'm wanting to reduce these, I'm going to put it on the inside. If I wasn't bothering reducing, or if I was actually solving and it was a number instead of x, it wouldn't matter. But since it's not a number, since it's a variable, and I want to be able to reduce this, I'm gonna put it here. And I'm gonna remember, when I'm taking the cube root, I'm looking for triples of something. So if you need to break it down, x to the 10th power means there's actually 10 x's. You could technically write x times x times x times x 10 times, okay? Or realize how many times will 3 go into 10? And the answer is 3, because 3 times 3 would be 9. So that means I can bring an x cubed out, because 3 goes into 10 3 times. But there's going to be some leftover inside, because that's not exactly 10. 3 times 3 is 9. And so I had started with 10 and I've only taken care of 9. So there's 1 left underneath. And I do not have to write a power of 1. A power of 1 is understood. Okay, so let's try that again here. So in the parentheses, everything is being raised to the 4th power. So the 2 is raised to the 4th power. And the x to the 1/3 is raised to the 4th power. So the 1/3 times 4 is 4/3. Okay, so this is what I'm at so far. Okay, so I can go ahead and do 2 to the 4th. So 2 times 2 times 2 times 2 is 16. And then x is to the 4/3 power. So the cube root of x to the 4th. Now again, how many times does 3 go into 4? And it's once. So x to the 1 power is going to be able to come out. And the 16 was already out there. But 3 goes in there one time and there's 1 left over. So I am still going to have an x to the 1 left inside. Okay, here, this one's an actual number. So this one I'm going to actually be able to evaluate. It's not going to have to stay an expression. But the 3 is the denominator, so that's the root. And the 4 is the power. Now again, I could do the 4 as a power inside, or I could do as a 4 as a power outside. When it's an actual number, I prefer to do it outside, just because it's easier to calculate the cube root of 8 than if I raised 8 to the 4th power. That'd be a pretty large number. So the cube root of 8 is 2, and then I've still got 2 to the 4th power. So 2 to the 4th power, we actually just did that up there. It was 16. So this comes out to exactly 16. All right, I've got another one that has a coefficient and a variable. So this exponent on the outside goes to both. So I've got, I can rewrite this all the 4 times the 1/3 for the x, but only to the 1/3 for the 4th. So they're both going to be under the cube root, but the 4 is not raised to a power. The x is. So I rewrote the 1/3 power as the cube root. And so then I cannot take the cube root of 4. 4 is going to have to stay underneath. Excuse me. But then 3 goes into 4, the power 4, one time. So x to the 1 power is going to get to come out. But there's 1 left. So x to the 1 power is going to have to stay in as well. All right. Here I'm going to do the same thing. I'm just going to rewrite this 1/3 power as a cube root. And then that's 64 x to the 6th underneath. The cube root of 64, I believe that's one that we can take the cube root of. So if you do that, some of you can do that in your head, some of you can't. Remember how to do that in Desmos. You have to go in to the function button and scroll all the way down to get your cube root. But the cube root of 64 is 4. So a 4 gets to come out. And then 3 goes into 6 twice. So a x to the power of 2 gets to come out. And there's no leftover. 3 goes into 6 exactly 2 times. So there's nothing left under the radical. The radical's gone. So it's just 4x squared. All right, here I'm going to rewrite that 1/3 as a cube root. Um, 5 is not a perfect cube, so I can't do anything about that. The 5 is going to have to stay underneath. And same thing with A and B. They're both to the power of 1. 3 doesn't go into 1 at all. So A and B both have to just stay under there. So we rewrote that, but there was no reducing to be done. All right, last 2 here. I'm going to go ahead and multiply those. So the 2 times the 4 is 8. So this is x to the 8/3, which when I rewrite it, it would be the cube root of x to the 8th. So when I simplify, 3 goes into 8 twice. So x squared gets to come out because twice is a 2. But when I do that, 3 goes into 8 twice. That's only 6. So that means there's 2 left. So underneath, I'm also going to have an x squared. If you're struggling to understand this or to break this down, think about it like this. X to the 8th could be broken down as x to the 6th times x squared. That's x to the 8th. And then the cube and the 6 you could bring out as x squared because 3 goes into 6 twice. Because remember, a cube root is like you're doing a 1/3, you're dividing the power by 3. So 6 divided by 3 is the x squared. But then this 2 divided by 3, that doesn't work. 3 doesn't go into 2 at all. So that's why that x squared had to stay inside. I don't know if that helps some of y'all understand it a little more. All right, here we're going to rewrite this as a third root or cube root. And then both of these are to the 4th power. So the 3 and the x. So 3 to the 4th power. You could do the same thing here and just worry about how many times the 3 goes into it. That actually might be easier than getting the large number and then trying to simplify. So 3 goes into 4 once. So that means 1 3 gets to come out, 3 to the 1st power, but you're going to have 1 left over. So a 3 has to stay underneath as well. Same thing for the x's. 3 goes into 4 once, so x to the 1 power gets to come out, but then you're left with a 1. So x to the 1 power has to stay in as well. If you're ever unsure if you've simplified correctly, you could plug all of these into Desmos. Like, look at this graph of the way that it's originally written. Type this in, it should be the same graph. Type this in, it should be the same graph. They are all equivalent to each other. It's just a different format and then simplified. So you're welcome to check any of those that way if you needed to. Especially on the test, if you were given this and told to rewrite it and it was a multiple choice, you could just plug the original in. I'll go ahead and show you. The original is 3x to the 4/3. Okay. Oh, and I had that as a dash line. I'll change it to solid. Okay, so that's what we started with. So what we changed and reduced it to 3x times the cube root of 3x. So let's see if that works. 3x then the cube root of 3x. Hey, looky there. See when you turn that on and off? That's the exact same graph. So that's one way you could work backward on the test from your answer choices as well. So just plug in the original, plug in your answer choices, and see which one is the same graph. All right, so that was that first page. Actually, I think I'm going to split these videos up. So this is end of video 1.